Hello everyone. Far, far away from the world, there is a mysterious planet near the edge of our solar system, Neptune. Due to its distance, this planet cannot be observed without an advanced telescope and was discovered as a result of observations. Could there be mysterious things on this planet that we are unaware of? It is suggested that Neptune, one of the coldest planets in the solar system, might support a superhot water ocean. Approximately 4 times larger than Earth, Neptune is an icy giant with a radius of about 24,622 kilometers and a volume of 62 trillion cubic kilometers. This makes it 58 times larger than Earth in terms of volume, similar to other ice and gas giants in our planetary system, composed mainly of water, methane, and ammonia. Unlike Earth, Neptune doesn't have a solid surface. Its atmosphere consists of methane and ammonia ice, and a rocky core mantle. However, scientists believe that Neptune theoretically could have a hot ocean beneath its surface. How can a planet so far from the Sun support such an ocean? It takes about 4 hours for sunlight to reach the surface of this giant. Neptune's average atmospheric temperature is minus 217 degrees Celsius, making it one of the coldest objects in the solar system. Additionally, recent research observed warming near the south pole of the planet from 2018 to 2020. Although a significant portion of Neptune cooled from 2003 to 2018 due to seasonal changes. The possibility of an ocean forming inside the ice giant remains unresolved. Some scientists suggest that gravitational compression or gravitational interactions between Neptune and its moon Triton could explain the internal heating. On the other hand, researchers Slan Viktorovic and Andrew Ingers believe there is a low probability, 155%, of ocean formation on Neptune due to its temperature. However, current calculations indicate a 40% chance of ocean formation after Neptune cools. Another possible explanation for the significant internal energy in the celestial body could be collisions with cosmic objects. Neptune radiates almost 2 times the energy it receives from the Sun, resulting in seasons similar to Earth's. However, on this massive planet, a single season lasts about 40 years, and Neptune's year is equivalent to 165 Earth years. A day on the ice giant lasts for 16 hours, creating super strong winds due to its rapid rotation. Neptune's atmosphere is composed of approximately 80% hydrogen, 19% helium, and about 1% other gases such as methane. The blue color of Neptune is derived from methane clouds in the upper layers of its atmosphere, as methane molecules can absorb shortwave solar radiation and reflect a blue color. Neptune, the closest planet to Uranus, has a similar gas distribution. However, unlike Neptune, Uranus has a pale blue color. Dr. Patrick Irwin from Oxford University suggests that this color difference may be due to the density of methane haze. Therefore, both planets' atmospheres have several aerosol layers. The deep layer below consists of a mixture of hydrogen, sulfur ice, and allows visibility of certain areas closer to the poles. For example, when we look at Neptune, we can see these regions in dark colors. The second layer, probably influencing the color of both planets, is a layer of ice particles where methane ice forms and can manifest as snow. Neptune's atmosphere is more active than Uranus, allowing it to create snow more efficiently. Consequently, the second aerosol layer is thinner, and the rich blue color comes from low-density ice particles. This layer is, in fact, an extension of the second layer. In addition to its intense color, Neptune is known for dark and white spots scattered all over its surface. These spots result from storms caused by the planet's rapid axial rotation, making it the windiest planet in the solar system. Wind speeds here can reach up to 1931 kilometers per hour, nearly 4 times stronger than Jupiter's winds. However, Neptune shares a similarity with Jupiter in the form of a large storm. The Great Dark Spot, a storm about the size of Earth, spinning at 2,414 kilometers per hour, was first detected by the Voyager 2 spacecraft in 1989. However, by 1994, the Hubble telescope observed the disappearance of the spot and the emergence of a new, smaller spot in the northern hemisphere. Unlike Jupiter's 300-year storm, Neptune's large vortices last only 2 to 6 years and consume themselves. In 2018, Hubble identified a new spot similar to the one discovered in 1989. The combination of these storms remains unknown, but scientists propose that the phenomenon originates from the depths of the atmosphere and forms over a few years. Researchers still have much to learn from these storms. For instance, the newly discovered spot in 2018 drifted southward the following year, disappeared, unexpectedly reversed its course, and began moving northward again. Moreover, a small storm had separated from the Great Dark Spot. NASA scientists proposed that this separation occurred during a fragmentation process. However, this event is yet unobservable. Larger storms, known as scooters, accompany these storms, characterized by white methane clouds moving faster than the Great Dark Spot. These clouds likely form above the vortices and subsequently freeze into ice crystals. Researchers suggest that these clouds, much like the storms themselves, could provide insights into Neptune's mysteries. Similar to gas giants like Jupiter, Neptune also has a ring system. In 2022, the James Webb Space Telescope captured a close infrared image showing the faint rings and moons of the ice giant. The last image of Neptune's rings was taken over 30 years ago by Voyager 2. In Webb's new photo, approximately 5 rings were visible, with each ring named after the astronomers who contributed to Neptune's study. The closest and most diffuse ring was named HY. This ring consisted of about 40% to 70% dust, measuring 4,185 kilometers in width and 2,000 kilometers radially. The second ring, Ulver, was much brighter but narrower, with a width of around 100 kilometers. The next ring, named Adams, was the widest and labeled as a complete ring with a width varying from 78-10 kilometer. The penultimate ring, Arago, was challenging to observe, being one of the smallest with a diameter of 57 kilometers, situated at the edge of Ulver. It went almost unnoticed due to its low dust content. Lastly, Adam's ring had an orbital radius of approximately 6,392 kilometers, with a narrow width of only 35 kilometers, making it Neptune's narrowest ring. Notably, the most significant feature of this ring is its arcs, mysterious bright dust lines encircling the ring. Each of Adam's arcs has a unique name, such as freedom, brotherhood, courage, and equality. These arcs particularly engage in material exchange and alter their dimensions. The origin of these arcs is still unknown. However, researcher Emily de Peter suggests that they may have resulted from the collapse of another object near the Roche limit. In addition to the rings, the James Webb Space Telescope recorded images of 7 of Neptune's 14 moons. The ice giant's moons were observed to be divided into regular and irregular groups. The image captured by Webb belonged to the inner regular moon, UA. Among these moons, Despina and Galatea are thought to be the source of dust in Neptune's rings. The most intriguing of the Webb images was of the bright moon Triton. Triton appeared significantly brighter than expected, resembling a star. This peculiar brilliance is attributed to the fact that Triton is almost entirely covered in nitrogen ice, reflecting about 70% of the sunlight that reaches its surface. Triton is, in fact, Neptune's largest moon, larger than Pluto with a diameter of 4,313 kilometers. Moreover, it accounts for nearly 99.95% of the total mass of Neptune's moons. Like all of Neptune's satellites, Triton is in a state of tidal locking, meaning only one side constantly faces the planet. However, due to its retrograde orbit, Triton's poles and equator alternately face the Sun. This unusual orbital inclination may be the result of Triton not forming alongside Neptune initially. Scientists propose that Triton evolved in the Kuiper Belt but was later captured by Neptune, which subsequently slowed down Triton's motion and prevented a collision with the gas giant. Triton's backward motion and inclined orbit set it apart from other moons, making it unique in our solar system. As Neptune has nearly 70 moons compared to Jupiter's abundance, it raises the possibility that Neptune may have had more moons in the past. Triton's peculiarities extend further when examining the close-up images taken by Voyager 2 in 1989. By analyzing craters on Triton's surface, scientists estimate the age of the materials on its surface to be between 10 and 100 million years. Some surface features suggest the possible influence of cryovolcanism, and there are basin-like depressions resembling lake basins. Therefore, Scientists speculate that Triton might have a subsurface ocean, possibly slowing down the freezing of water due to the presence of a considerable amount of ammonia beneath its surface. Triton's thin nitrogen atmosphere is believed to be generated by the sun's heat, similar to Enceladus. However, it is currently inconclusive whether Triton, like Enceladus, may harbor conditions suitable for the development of life. The Kuiper Belt is a region beyond Neptune's orbit that includes thousands of celestial bodies such as asteroids, comets, and dwarf planets like Pluto and Eris. It extends from about 30 astronomical units to 50 astronomical units from the Sun, marking the boundary of our solar system. Neptune's gravitational influence plays a crucial role in the dynamics of the Kuiper Belt. Some objects in the Kuiper Belt, including Pluto, are in long-range resonance with Neptune. This resonance ensures that their orbital periods periodically align with Neptune's, preventing them from drifting away from the solar system. Scientists believe that Neptune's gravitational effects may have played a role in the formation and evolution of the Kuiper Belt. Furthermore, Neptune itself appears to have migrated in an event known as planetary migration, transitioning from its original formation location closer to the Sun to its current position. This migration likely influenced the distribution of objects in the Kuiper Belt, helping many celestial bodies remain within our solar system. The precise composition and internal structure of Neptune, as well as the formation of ice giants like Neptune and Uranus, continue to be subjects of ongoing research. Hopefully, future space missions and scientific inquiries will further expand our understanding of these distant and mysterious worlds. What are your thoughts on these discoveries? We look forward to hearing your comments. Until the next video.